All right. Well, I guess we will go ahead and get started. Welcome to our first AEESP Education Committee webinar for the academic year of 2025 to 2026. My name is Stephanie Lawton. I'm one of the members of the Education Committee, and I'll be acting as your host and moderator for today. You can see that we have our three panelists on the feed. And they will be going through and giving some expertise that they have developed through the years on how they develop the global mindset in their engineering education students. Let us go ahead and hop in then. All right, hopefully we all see the first slide. Susan, if it is not going through correctly on your end, please let me know.
That's good.
So, first off, what is the global mindset? Pulling from a couple of different sources and piecing together that information, the best definition that I was able to supply is the ability to understand, adapt, and work effectively across cultures, contexts, and perspectives. So, in the context of our engineering students, this is being open to different ways of thinking, appreciating different cultural, societal, and environmental dimensions that are in engineering problems. And then as they advance into the profession, being able to apply their technical and professional skills in ways that are respectful and relevant in the diverse settings that they will work in the future. Now, the key thing here, unlike a lot of what we do in engineering education, this is a mindset rather than a technical skill set. I kind of hate to make that definition, but it is what it is. There is no calculation where we can measure right or wrong if a student has had the proper global mindset. Instead, this is something, a perspective, a thought process that we hope our students achieve. With global mindset, it is something that we have to keep an eye on for accreditation purposes. If your school is like mine, we are ABET accredited, and therefore we have to rely on coming up with ways to assess internally what we are doing and demonstrating how we are showing student success over time with our curriculum. For ABET, Student Outcomes 2 and Outcomes 5, we do actually have specific calls for global thinking and global mindset, whether it is in the application of engineering design for solutions, or it's in recognizing ethical and professional responsibilities in a wide range of engineering contexts. Today, what we're going to be doing is working through our different panelists, showing their experience, both examples of development of global mindset at home on their home campuses through classroom-based activities or campus-based activities, as well as development of the global mindset through travel, such as study abroad, international research collaborations, that sort of thing. And then the hope is that, especially if you are a junior faculty member or potentially a future faculty member, you'll be able to walk away with some practical strategies or some inspiring ideas of how you are able to also integrate global perspectives and the development of global mindset in your students as well. So a quick example from my own teaching practice, because I joined the Citadel in 2020 at the height of COVID, I wasn't necessarily able to take students off campus or definitely out of the country at the time, and therefore had to come up with more classroom-based exercises on how to develop the global mindset. For this particular exercise, after introducing the UN Sustainable Development Goals, which you'll find is a theme in some of our presentations today, I have the students select one of those Sustainable Development Goals to go in a little bit more depth. And given some recent changes on campus that are emphasizing the use of AI, this has actually more recently become a discussion board assignment where students are prompting AI to act as various characters, if you will, from around the world, and then reporting on the results of that generative AI role play. and really thinking about what assumptions or stereotypes, what biases may show up in the content generated by Gen AI, and how that may or may not be the global reality. Here is a quick screenshot of something that a student would be able to submit their question, asking Gen AI, in this case ChatGPT, to role play as a farmer from Kenya and think about the Zero Hunger Sustainable Development Goal. The student sees the response, posts about that, and then posts their reactions thereof to start questioning some of the biases they may have or they may see in generative AI because of the limited data sets that are presented for that. Now, a couple of housekeeping items as we transition into our three expert panelists. Each panelist is presenting their own experiences and perspectives, so keep that in mind. Some of their statements may be opinion statements rather than concrete fact. We will be having an open question and answer at the end. Throughout their talks, if you have questions, feel free to put them into the chat box, but we will be addressing all of those questions at the end of the webinar. As you may have heard, the little pop-up at the beginning, this webinar will be recorded. So if you feel the need to be anonymous in your comment, feel free to be in the Q&A. And then if you do want to inquire for more specifics from any of our panelists, all of their emails will be provided on the screen during the Q&A at the end, so you can jot those down and reach out to them directly. Now, you see my picture, unfortunately, on the screen as the moderator, but our three expert panelists are the ones that I want to draw your attention to. Our first presenter is going to be Dr. Annalisa Onis Hayden, who's a teaching professor and vice chair of undergraduate studies in the College of Engineering at Northeastern University, and she is in the Department of Civil and Environmental Engineering. She'll be followed up by Dr. Kevin Orner from West Virginia University, where he's an assistant professor in the College of Engineering and Mineral Resources, specifically in the Department of Civil and Environmental Engineering. And then our last panelist is going to be Dr. Dan Orther, who's a professor in the College of Engineering and Computing at Missouri S&T, and he's in a bit of a more diverse department, the Department of Civil, Architectural, and Environmental Engineering. All right, so I'll turn it over to Annalisa for our first panelist presentation.
Hi, good afternoon. Thank you, Stephanie, for the introduction. So, again, I'm Annalisa Oniseda, and I'm a teaching professor at Northeastern University in Boston. And what I'm going to try to do for the next few minutes is give you a little bit of my experience with teaching sustainability in a study abroad context. Next slide, please. So what I'm going to try to convey to you is talking a little bit about how Northeastern does this Dialogue of Civilization. It's a short study abroad program. I'll discuss a little bit more how I developed my idea of a sustainable waste management Dialogue of Civilization, how that program is structured, the type of assignment that probably provide a couple of ideas, maybe a suggestion for something that you could integrate in some of your classes, the impact that I've seen on students, and then wrap it up with some conclusion. So what is the Dialogue of Civilization at Northeastern? So Northeastern has about 70 Dialogue of Civilization. It's a faculty-led program that it's completed during, we have a weird semester structure. So we have 2 summer 1 and summer 2. Those are about 8 weeks long semester. And during this time, we can provide an experience, a study abroad experience that it's led by one of the faculty, 1 or 2 faculty. And typically the duration is a little bit intense, 4 to 6 weeks, pretty intense program. And a lot of the program focus on critical issue facing society, both at the local and global level. And the faculty brings to the host location group of students, anywhere between 15 to 30 students. And it's a great experience for short-term international experience, different than your traditional long study abroad, semester long, 4 to 6 months, depending where you are at your school. The Civil and Environmental Engineering Department actually offer 3 dialogue of civilization, all around sustainability theme, sustainable transportation in the Netherlands, climate change and adaptation in various locations, and the one that I lead in Italy, specifically in Cagliari, focus on sustainable waste management. And that's while there is a little bit of sustainability and open to a lot of our environmental engineering students, the one that I develop, it's specifically developed for environmental engineering students. So to dig into a little bit more about why sustainable waste management was chosen as a topic. Well, first of all, this dialogue of civilization are open to a variety of students, so not necessarily environmental engineers. So while environmental engineers usually make up 80 to sometimes 99% of the population that comes on this dialogue, the specific topic has a lot of additional component beside the technological, social, political, economic, and makes it the theme or waste management ideal topic for a diverse group of students, but also for even when only having an environmental engineering student, to think beyond that, just the technological aspect. Why in Sardinia? Well, first of all, that was my University of Cagliari is my alma mater, so going back home, it was not a bad thing. But I choose actually to go back home and working on waste management because the university has been a leader for a long time in waste management research, and they are one of the co-hosts of the largest waste management symposium in the world since the 80s. Europe in general has a lot of good practice and good example to how sustainable manage waste. So I found that learning from the European Union and compared to the US, it's a great way for the students to see a different perspective on several aspects. And in addition, it's a beautiful place that we get to go and experience. So the student not only experience and learn about the topic, but have the opportunity to explore the culture, the nature and tradition, and get a little bit of a learning how other people live in different places. So that was the reasoning why. So how do we do that? Next slide, please. So I teach 2 courses. One, it's a little bit more on the technical aspect, and it's focused on technology and management strategy, focusing specifically on material and energy recovery from waste. We have done a second course that it's more a little bit larger view and looking at policy and looking at the case study of Sardinia, Italy, and the EU for comparison. Now we do this through the 5 weeks that I spend in country. It's pretty much every day, pretty long days, but we have a traditional lecture, guest speaker from academia, the government, the industry. We have a weekly technical visit. We work a lot on team. The students work on 3 different projects. And during the weekend, we enjoy the lively cultural experience and the space and the environment in Sardinia. Next, please. So what are the central theme? The major central theme, of course, is Sustainable Development Goal, specifically the 11, 12, and 13, understanding how to create sustainable cities and community, discussing responsible consumption and production, and of course, climate action. And the central theme throughout the 5 weeks is the circular economy concept. As developed by the Ellen MacArthur Foundation, that students see this for the pretty much every other day for the 5 weeks, and really to try to dig into that component of this circular economy and what it takes to make a circular economy on that for waste. Next slide, please. So we do that through lecture, but some of the picture here show some of the guest speaker and activity that the student do. We get to explore the organic fraction of waste. So we visit composting plant, anaerobic digestion, all the way to a concept of biorefinery. And so advanced topic of circular economy and looking at the research producing bioplastic, for example, for waste. Also, we take them to various technical other visits to explore our material. It's turned into a new product or our electronic are disassembled and repurposed. So the major things that we do, the students spend a lot of time on group projects. There are three main projects that we work on. That I call them the policy project, the science project, and the engineering project. At the beginning, there's not a lot of understanding or knowledge of the topic, so the students really do a research on policy on European and US. They are given a specific waste stream, organic fraction, construction and demolition waste, e-waste, and they try to see how that the waste stream it's managed on a policy and regulation, both RECRA for the US or state regulation and the European Union. The Science project, I'll talk a little bit more about that because actually that's pretty easy to integrate in other courses. And it's evaluate environmental impact so of waste management scenarios. And then the final, at the end of the 5 weeks, the student have seen, experienced, learn through lecture visit. They're actually ready to make their own plan. And I gave them the city of Boston, and they need to try to make a comprehensive waste management plan, including calculation, policy recommendation, and implementation strategy to make the waste management in Boston more sustainable. So the science project, just a little detail, because I think we need, as environmental engineer, we should be taking advantage of existing software that are available to us. The EPA has created this waste reduction model that allow to pretty simple with just an Excel spreadsheet to determine greenhouse gas emission. It's an LCA-based approach. And what I give the student, each group is given a European or US city. They need to research the current waste generation, how they manage the waste, how the city manage their waste, and identify what is the baseline scenario. Then they have to come up with the alternative scenario. For example, if I follow the European Union's goal on reducing organic waste or moving into recycling or anaerobic digestion, what does it gonna mean for that city in terms of greenhouse gas emission? And then they have, of course, to pick what is the best scenario that they feel for that city, but how they will implement it, what is gonna have to change. And to do that, they really need to consider trying to understand how the people will react to those changes and how the technology will have to adapt or how the policy will need to be put in place for those changes to occur. So I think it's pretty impactful, the students over the year. I ask feedback and what I've observed. These are just from the students' response. It's behavioral change. Like I started home composting, or I can't buy any more of that product because now I'm more aware of the impact. But also career selection, really getting passionate about as something that they've seen firsthand. And in terms of cultural awareness, really participating and seeing how the people there behave on the waste management side, how they separate their waste or how they think about waste on a day-to-day, or how the engineer think about it, this issue, but also just visiting the island, give them a much more appreciation of or their role as environmental engineer. So, and that's important. So just the next slide, please. So concluding, I think if you have the opportunity to create this type of program, there could be very impactful. It's At first, it's a great opportunity to teach sustainability principle and first have a lot of opportunity to do experiential learning with the integration of lecture, discussion, and visit. But the team assignment also provide that opportunity and live for in contact with the culture definitely does have an extra so that they can appreciate the diversity and help them create a global citizen. And my last slide is just thank you to, I've been doing this for 10 years. So those are 10 years of dialogues. So those are all my students. So about 130 students have been impacted over the years. And I've just the one group that is did the 10-year anniversary coming back to Sardinia to really go back and to see the changes. So it's been great to have that experience. Thank you.
All right. Good afternoon, everyone. My name is Kevin Orner. I'm an assistant professor at West Virginia University. And in my section, I'll have one example of global competency in the context of an NSF IRES, International Research Experience for Students in Costa Rica. And then in the second half, I'll cover how I've tried to integrate global competency in a classroom setting here in West Virginia. So first, I'd like to start out with global competency in the cloud forest. So this is through an NSF IRES grant. So it's typically about $300,000 of funding. And the idea is that you've got 3 different years or 3 different cohorts of students that you can collaborate with an international organization, take students down, and the students will have an international experience. So in my case, the students are there for 6 weeks per summer. Costa Rica is fairly close. It's a little bit easier to get to. Other IRES programs, it could be 4 weeks or 5 weeks. So it kind of depends on how costly it is to get there. So it was 3 different universities, not only West Virginia University. We also had Pablo Cornejo, who's at California State University in Chico. He's on the call today. And then we also had 2 anthropology faculty from the University of South Florida. So the idea is that in the fall, we would be recruiting to our students. We were open to both undergraduate students and graduate students. So sometimes we got more graduate applicants, sometimes we got more undergraduate applicants. So we would recruit 2 students from each university. So here at WVU, it was 2 engineering students, a mixture of grad and undergrad. Chico is mostly undergraduate, so we had 2 undergraduate engineering students. And then from the University of South Florida, we had 2 anthropology students. So it's a really nice mix of disciplines and universities and being able to interact with one another and then do some great research together in an international context. So we did our recruitment in the fall. Back to the last slide. And then in the spring, we would review the applications. We would have them do a written application and then had the finalists interview with us and then eventually had selection. And then we had a 4-day virtual training in May before the students left in June. All right, next slide. So the reason why we went to Monteverde, Costa Rica, one was that all 4 of the PIs had previous experience in the area. I did a Fulbright in Monteverde back in 2018. Pablo Cornejo did his sabbatical there a little bit later. And then our 2 anthropology faculty from the University of South Florida, they did a field school there for 15 different summers between 2000 and 2015. So we all had previous long-term experience there. And then we had a great host organization in the Monteverde Institute. So in this area, there was both kind of an urban core and a semi-rural area around it. And it's really known for bringing in tourists for ecotourism. So here you see a picture of a hanging bridge in the cloud forest. So in addition to the 6,500 residents, you would get 250,000 up to 500,000 closer now visitors per year, and that is loaded during the dry season. So the dry season is a great time to travel. It's also when you get the least amount of rain, so the least amount of drinking water. So that presented some issues for drinking water and for wastewater. Other problems, challenges that were identified were with existing septic systems. One challenge was that installation typically meant having walls but no floor on the septic systems. They were advertised as having the benefit of not needing emptying very often because all of the liquid was infiltrating into the soil. And it was also 2 hours for the septage to be hauled down the mountain to get septage management at a wastewater treatment plant. So these so-called honey wagons would often collect the septage, and then instead of accruing the costs of transportation and tipping fees, they would just find a spot on the hill late at night and just empty out your septage, which obviously has some environmental implications. In order to have some of these septic tanks not fill up quite quickly, they would not put gray water into the septic tank, but that would often just be drained into the street or into the yard. So all these things led to some aesthetic concerns for an area that is highly dependent on ecotourism, and obviously some public health risks associated with that as well. Next slide. So our approach was that students would have not only an international experience, but also an interdisciplinary experience. So we had two engineering faculty, two anthropology faculty, four engineering students, two anthropology students, and we would cross-train the students. So engineering students weren't just doing engineering methods, they were also learning how to do interviews and surveys. The anthropology students weren't just doing the interviews and surveys, but they were also learning how to do water quality sample collection and analysis. So on the figure on the left there, we were doing some practice water quality measurements of just collecting water from a local stream before we took those samples back to the lab. The picture on the right is one of the classrooms at the Monteverde Institute. So it's a beautiful setting to look outside at the cloud forest and then learning how to do some of their anthropology exercises before they practiced with the Monteverde Institute staff and then did the interviews and surveys out in the community. So the idea was we would take the water quality data from Objective 1, we would do interviews with locals and experts in wastewater treatment, and then do something called free listing, where we would say, write everything you think about composting toilets and then separate that into different piles and then rank their priorities and take all that data collection together to do some holistic sustainability analysis between different scenarios. So integrate water quality, we would integrate some life cycle assessment, life cycle cost analysis, along with some of these social anthropology data collection methods. Next slide. So out of the 3 years of the NSF IRES project, the first year was in 2024, in June, July, and August. So that focus was on decentralized wastewater technologies, so composting toilets and septic tanks. So here we are, we went to a local hotel that had some septic tanks. So we talked to them and we were able to do some sampling and analysis. That large tube there is called a sludge judge. So that's a great way to take a sample and we would bring back to the lab for analysis. We did some solids testing, some nutrient testing, and then we sent some samples to the University of Costa Rica for testing as well. Next slide. This past summer, we focused on what they call biojardineras, biogardens for gray water treatment. So the idea is that the gray water is often treated separately or not at all from black water. So one way that you can treat it is by putting in the subsurface constructed wetland. So the idea is that we could do some sampling at the start and at the end to see if these biogardens were effective or not at removing different constituents like nitrogen, phosphorus, solids, and so on. Next slide. And the idea was we would bring all this water quality data together, all of the anthropology data together. In this past summer, we had 6 different locations of testing, and then we did some multi-criteria decision analysis where we could look at different social sustainability metrics, some economic sustainability metrics, and different environmental sustainability metrics, and be able to compare scenarios with one another, with the idea being this could inform both current operation and future implementation of technologies in the area. Next slide. So moving on to the second topic of global competency in the classroom. One class that I teach here at West Virginia University every spring is Sustainable Development Engineering. I'd like to give a shout out to James Mihalsic. I originally took this class as a student at the University of South Florida and then modified it for use at West Virginia University. So this class covers different topics like sustainable development goals. One thing that's rather unique is something that we call SDG 360 thinking. So I'll put it in the chat here. So this is basically an approach that was developed at the University of Wisconsin to be able to translate these global sustainable development goals and to put it into practice at a local level. So it has some visualization capabilities of saying, if I'm working on a local project, which sustainable development goals are most relevant, which targets are most relevant, and then having students be able to put all that into a visual that's very appealing to look at. We also do participatory approaches. So I was a Peace Corps volunteer in Panama back in 2009, and we did some community mapping exercises. So I have my students go through a community mapping exercise in class and then do a same mapping exercise either with a roommate or with a family member as a homework assignment. And a lot of the feedback I get from that assignment is that their roommates or their family members always want to know what the students learning at the university campus, so they felt really happy to be a part of their students or their family members' learning experience. I do a section on science and policy and then cover water and wastewater in low resource settings. Next slide. One unique thing that I've implemented that could be implemented at other campuses is semester projects. So my goal here was I didn't want students just to do small homework assignments or just have different lectures on these topics. I wanted them to get their hands dirty. So I found a really good campus collaborator who's a part of facilities at West Virginia University. He also does campus stormwater management. And he and his crew are really understaffed. So when I talked with him, he was really excited about students learning about different stormwater management, best management practices on campus, because there's a lot to maintain and not enough time for his staff to be able to maintain or improve a lot of these best management practices. So each semester I have students look at a few target areas on campus where my collaborator has identified that there are some issues with stormwater management. So the students go down, they observe how it's acting when it's dry, when it's raining, if there are opportunities for improvement, and then put together a design, a budget, and then we work to get all those materials and actually do implementation at the end of the semester. So in the top right, there's some stormwater infrastructure on campus where the water was flooding over that road there into the parking lot whenever it was raining. So we put in some cinder blocks and some grass and some additional rocks so that the water would go into the drain as it was designed rather than just flowing over the street there. On the lower left figure, there's a greenhouse on campus, and they were really interested in collecting rainwater for irrigation of their plants inside. So we were able to do some sizing and then eventually got these really large rain barrels and do some installation of that all within the context of one semester. Next slide. And what I'll finish with today is some hands-on homework assignments. So there are many students who really like the math and the homework exercises. There's also a lot of students who might not be as prepared with some of the more quantitative homework assignments, but really love getting their doing some hands-on homework assignments. So I have students near the start of the semester do hand pumps. So this was something we originally did at the University of South Florida. So they have a $50 budget. They go to a local hardware store. I give them 1 or 2 YouTube videos to kind of give them an idea of what designs and what materials are needed. They end up buying everything, putting everything together, and then have a competition to empty a 5-gallon bucket during our hand pump competition. And then on the right, we do some rocket stoves where we have what we call an innovation hub on campus where they have some access to different ways to different tools available to work with metal here. And then we have a place on campus where they can actually do a boiling test where they can, build a fire and then see how long it takes for water to boil using their rocket stove. So these are just some ways that, with a grant and with a lot of resources, you can do something in an international context like Costa Rica. But there's still a lot of work you can do even on your own campus to make your campus infrastructure better and give these students a hands-on experience where they can learn these things and put them into practice. So I'll stop there.
Well, hi, my name's Dan Other. I'm at the Missouri University of Science and Technology, and I don't know about the rest of you folks, but I've been incredibly inspired by the presentations from Annalisa and Kevin. So when we were putting together this slide deck, I thought, wow, how am I going to be able to work in this same space? So I thought, what I'm going to do is try to take and synthesize a little bit from what I've seen from some of their slide decks, and then apply it a little bit to how I'm doing my own work and maybe kind of weave together a little bit of a story. And so I've titled this From Designing Widgets to Solving the Problems of Planetary Health. How do we scale up engagement to create new paradigms in environmental engineering? And I want you to leave with 3 important lessons. The first one is you don't really need to travel far to find ways to help others. The second is remember you aren't working in a vacuum. And 3, do it your way. Now, the presentations we've already heard have clearly emphasized that you can do stuff international and you can do stuff local. So I'm going to explain my view of that, but you really don't have to travel far to help others. Second, the 2 presentations also explained that there's an awful lot of folks out there to work with, to partner with. There was some name dropping of great people out there that have been, pioneers in the profession. So you aren't working in a vacuum. So while it can seem overwhelming and challenging to work in this space, it's really not. There's a lot of folks that'll work with you. And I'm kind of known for doing things a little bit in my own way. And so I'm going to conclude with a little bit of taking some of these lessons and then applying it to how you might do it in your own way. So if we look at the next slide, we're going to see just a couple of examples. Now, my first kind of project in global mindset would actually be doing an Eagle Scout project way back in high school, or making my first trip to Bolivia when I was a sophomore in high school. So I've been doing this for roughly 40 years. I've helped, depending on how you want to count it, somewhere around 500,000 people in about 24 countries around the world, including a bunch of sites here in the United States. So we've helped people get access to water in Tanzania with biosand filters. And we've helped promote vaccination and medical care in places like India, the world's most populous country. But even domestically, locally, 20 years ago, we took a bunch of abandoned plots in urban Cincinnati and converted those over into farms, places for people to be able to grow food. And 10 years ago, my wife and I and our 2 small children, this picture just has 1, actually kind of demonstrated sustainable living by living in one of those US solar decathlon, student-built solar decathlon homes. So yeah, we had 4 people, including 2 little kids, in 1 bedroom with 1 bathroom, 500 square feet. Awesome experience. So lesson 1, you don't need to travel far to help others. There are all kinds of things you can do. So talk to the local folks at your university, whether it's your custodial folks, whether it's your agriculture and garden folks. There's all kinds of stuff you can do everywhere, including applying for NSF or other funding and going and traveling overseas. The next slide is to let you know that you don't do this all in a vacuum. So whether you are familiar with Stephen Dental, who passed away a number of years ago, who is the namesake for AEESP's Global Engagement Award. So if you're looking for how do you get recognition, maybe you apply for AEESP's Stephen Dental Award. Or maybe you look at where AEESP and the American Academy of Environmental Engineers and Scientists co-sponsor the Poland Medal, which is recognizing a person who bridges education, research, and practice. So there are awards out there, and then there are examples. We already heard some name dropping of folks in this, but just a couple of additional names to add to. Folks like Bernard Amadei, who founded Engineers Without Borders in the United States. Folks like Joe Hughes and many others, including Arnie Vestlin and others that are in this space that are working on peace engineering. Joe's at Drexel. There's a whole lot of stuff out there that you can leverage, so you aren't working in a vacuum. So slide 3, well, how can I say that this is true? Like, what's my inspiration for this? So in 1979, when Mother Teresa received the Nobel Prize, a journalist said to her, how would one best promote world peace? And Mother Teresa simply said, if you want to change the world, go home and love your family. And so we don't have to travel far to be able to help other people. And I would actually suggest that if we want to do things that are going to actually make the world better for everyone, we don't have to look any further than what it is to be an engineer. And on the next slide, we'll see how the U.S. Department of Labor, particularly the Bureau of Labor Statistics, defines the various disciplines of engineering, like civil engineers. They plan, design, supervise construction and maintenance of building. Are you getting the pattern here, right? Electrical engineers, plan, design, blah, 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 right? Like it's kind of almost puts you to sleep, right? So it seems like, what do engineers do? We've got these words like design and build, and then we focus on these different widgets. And it's really awesome, and it's really future focused, and it's really about creating this new world, but it doesn't really get at the question why we engineer. It's really good about the how and the what, but it really doesn't get us at our motivation. And engineers need to have a motivation for what they're doing. So in 2023, working with a group of folks, I redefined the profession of environmental engineering. The next slide shows the current definition. Environmental engineers use engineering disciplines in developing solutions to problems of planetary health. It is the only definition out of the 20 plus definitions of different flavors of engineering that's actually like, why? Why do you do it? Because I'm solving people's problems. Why? Because I'm interested in the problems of planetary health, right? Like it's a concrete answer to the question of why we do what we do. But some of these words might be a little unfamiliar to you. In the next slide, we're going to unpack this term planetary health. Now in 2015, a Lancet commission, for those of you that aren't familiar with kind of like the UK and Europe, right? Think in the United States, the Journal of the American Medical Association, right? Like all the physicians, surgeons, nurses, they all get together and publish their best stuff. Well, in Europe, you might think about like the Lancet. So, hey, people getting together and publishing their best stuff. So a Lancet commission working with the Rockefeller Foundation came up with the definition of a new transdiscipline, a new field. Planetary health is a solutions-oriented, transdisciplinary field and social movement focused on analyzing and addressing the impacts of human disruption to Earth's natural systems and that disruption impact on human health and all life on Earth. This is the infographic they put together at the time. So if we start up there where we say planetary health, we say the human population has never been healthier. It never has. We've never lived as long. We've never had as low mortality for moms. We've never had as small amount of diarrhea as we currently have. And the reason for that is because from 1950 till now, we've had an explosion, what we know as the Anthropocene. There has been a tremendous growth in all kinds of technologies. Now, you can trace back to like 1800s and think about the Industrial Revolution. But really, from the end of the Second World War on, we have been in what's called the Great Acceleration. And the thing is, this third set of this third one in the middle panel, right, our current trajectory puts us even more pressure on the planet. This is known as planetary boundaries. These are the things that the planet can provide to us that we are starting to exceed. And we actually know we are slowly killing our planet. Healthcare professionals care about this, right? Because if you destroy the system upon which human health depends, then human health will be impacted. And so up here at the top of the one on the right, damaging the planet damages human health. So we have never had as good as allies, as strong as allies as we do now in environmental engineering to help us do our work. The professions of nursing and surgery and medicine, they're interested in safeguarding human health by maintaining the health of the planet on which we depend. Well, my friends, if you're in a car wreck, you want to go see a surgeon or a doctor. If you're trying to struggle with like breastfeeding, you might talk to a lactation. If you want to save the planet, you need to be talking to environmental engineers. That's our bread and butter. We know this stuff. So how do we step forward and lead this? Well, on the next slide, I would actually suggest that one of the things we have to do is free our minds from some bad ideas. Now, look at this diagram on the right, this Venn diagram. We use it all the time, right? Sustainability is the intersection of people, planet, and prosperity. And there's equitable and livable and viable. Blah, nonsense, nonsense. Our conceptual framework of sustainable development is fundamentally flawed. Point to me a place where you find people minus planet. There's no spot. We're not living on Mars. Tell me a place where there is some definition of prosperity that doesn't depend on people placing value on something. It doesn't exist, right? This is not actually a Venn diagram. Sustainable development is the overlapping target of these three things. Planet's the biggest one, people within that, prosperity within that, and the target would be sustainable development. So our common framing, our common definition, meeting the needs of the present without compromising, these are flawed. They're anti-technological, they're anti-development, they're anti the direction that we want to go. So what does it look like to have some new definitions? All right, let's go to the next slide. All right, so I would argue that we need to move from I to T to V shape in our professions. I shape folks, right? BS, we know what that stands for, Bachelor of Science. MS, we know what that stands for, more of the same, Bachelors of Science. And PhD, pilot higher and deeper, right? I shape, we have more and more and more of our stuff, right? T shape means I spread out a little bit while I'm I shaped. I'm encouraging us to become V-shaped professionals. I don't know if this is the way that Churchill did it or this way. One of them's okay and one of them's wrong, but focus on being V-shaped. What does that mean? You bend a depth of specialization in one discipline and a depth of specialization in another discipline towards a common future. Now, some of us would see ourselves as pioneers in this space, creating these new disciplines. Some of us might be guides. We help people move between them. Others might be translators where we adjust our language. And if you're wondering, where do you go from STEM to STEAM to STEMpathy to V-shape, on the next slide, you simply go to art. You see, artists already have the idea of V-shape. It's called the vanishing point. When you have a flat, two-dimensional drawing and you want to make it look three-dimensional, you pick one point. You pick the future that everyone aspires to. And then you point all disciplines to it. The way a two-dimensional drawing becomes three-dimensional, the way it has depth and meaning, is through the vanishing point. My argument is that our disciplines are all pointing towards a common vanishing point, a common future for the sustainability of the planet and humanity inhabiting it. So let's figure out what that vanishing point looks like, and let's aspire to work towards it. So how do we get there? Well, on the next slide, I would argue that we need to have better frameworks. On the right, here's a framework that I put together with some nurses this past year. The idea of human flourishing. Like, we tend to do these projects like a water supply system or a sanitary project, right? We forget that moms need to have nutrition before they ever get pregnant to be able to have proper antenatal care, right? Like, caring for people goes all the way to grieving after someone dies. When we're thinking about life cycle assessment and we're thinking about sustainability, my friends, the biggest place where we invest resources without a whole lot of gain is keeping people alive the last 2 or 3 months of their life. I'm not suggesting we let people go, but I'm saying we tend to obsessively focus on early life, on water supplies, on sanitation, and we almost exclusively ignore people falling in old age, people suffering from dementia, people having problems feeding themselves. Why are we obsessed on one end of this spectrum instead of recognizing the entire life cycle? And second, there's a bunch of us that are working together on a new educational paradigm. So this language that I've got on here, this group of us that is working for the National Academies of Science and Engineering and Medicine, we're an ad hoc committee on education for thriving in a changing climate. And I think you'll appreciate this because we're looking for evidence of how education plays a role in helping individuals and communities understand and respond to a changing climate. In addition to bringing in STEM skills, we want to know the attitudes, knowledge, and forms of reasoning required for civic deliberation and cogent decision making. You heard in the other two presentations, anthropology, decision making, policy. We can't just do STEM stuff separate from understanding the bigger issues. And the way we really get at this is we fundamentally change what it means to be an engineer. If I was to go in your classrooms and I was to say to your engineering students, what is the most important thing about being an engineer? Every single one of them will regurgitate back to me to hold paramount the health, safety, and welfare of the public. And as we see on the next slide, that phrase has been around for quite some time. It was in 1976 that ASCE first adopted it. IEEE has that same framework. The American Society for Mechanical Engineers has that same framework. As we started this presentation today, we talked about ABET 2 and 5 criteria. It's the same framework. NCEES, who makes the professional engineering exam, has the same framework. Do you know the discipline that's ahead of us? Chemical engineering. Chemical engineering says that their paramount clause, their main reason for existing as a discipline, is to hold paramount the safety, health, and welfare of the public and protect the environment in the performance of their professional duties. That's a game changer, my friends. That's a new way of doing things. So I recently wrote an article, it's in review, where I'm proposing that we fundamentally change what it is to be a civil environmental engineer. It is no longer sufficient for us to hold paramount the health, safety, and welfare of the public. Our job should be to hold paramount the health, safety, and welfare of the public and the planet. Full stop. All right, last slide, please. Do it your own way. I hope I am inspiring you. Now, not that I am Albert Einstein, but when did Albert Einstein make this quote? We can't solve our problems with the same thinking we used when we created them. Well, he actually never said that. It's a paraphrase of some things he did say. Albert Einstein's great mind contributed to us knowing how to kill ourselves with atomic bombs. And people ask Einstein, well, how are we going to grapple with not having nuclear winter and destroying humanity? And Einstein said, the problem is that all the great minds that created the bomb are not going to be the same great minds that solve the problem. Well, my friends, it is our opportunity to solve the problem of sustaining our planet. Let us not make the mistake of applying the same mindset that created the problems of our deteriorating planet. My final slide summarizes, I hope that I've convinced you that you don't have to travel far to help others, that you aren't working in a vacuum. And if anything I've left you with is please, please, please do it your own way and have new and creative thinking. Thanks so much for your time and attention. I was really excited to be here.
All right. Thank you to all of our panelists. For our attendees, this is our open question and answer period. If you would prefer, you can type any questions you have directly into the chat and I'll read them out to our panel. However, since we are a relatively smaller group, Dr. Susan has also volunteered. If you prefer to unmute yourself, please just raise your hand on your webinar screen and she'll be able to navigate unmuting you so you can verbally talk with our panelist. Now, as we're waiting for our first questions to come in from the chat, I will go ahead and pose one to the panel for discussion. So kind of building off of what Dan was just saying, where we want our students, when we're thinking about developing a global mindset, or global mindset not only for the people, but also for protection of the planet and the environment, we want them to not only have technical skills to be able to accomplish that, but also the interpersonal and social skills that we may be able to acquire from our anthropology colleagues or those in political science. So how would you address a student that is really excited about one or the other, but is maybe not showing as much talent in both? How do you encourage them to develop that skill set that they may be missing to become a well-rounded engineer?
V-shaped professionals, they should be focused on the future and bringing those skills together. So I work a lot with nurses because I'm horrible at those, what we're now calling durable skills. At one time we called them soft skills, then we call them professional skills. Now we call them durable skills in the world of AI. right? I'm just bad at that. That's not who I am. So I tend to work with nurses because they've got a lot of the same quantitative skills that we have, right? Like measuring blood pressure, knowing doses of drugs, but they also have an awful lot of skills from those anthropology and education. So that's how I solve it. But it's a great question, Stephanie. So I actually I'm an adjunct faculty member at a program where we actually train people to get a bachelor's degree in engineering and in nursing at the same time. And that's to create actually a new V-shaped professional.
One thing that we are trying to do is develop program like combined major that match different type of experience. So we have a combined major environmental engineering and health science so that you can get the best from the two discipline and the two understanding and also get in the contact with the other student. They might not be the best, but I think even just be in the same classroom and work on project and other assignment with other students that are more deeper in that discipline provide a good overview and good understanding. So that's one way to do it, right? Create new program that instead of going deep, right, try to really expand and try to see the connection. We are not working in a silos. We need to work with others. And if that, we can start proposing that type of program or at least identify the courses that our students should take. That all of our students have general elective, and sometimes it's hard to tell them which one to take, but I think there are opportunity there for learning. So we don't have necessarily to teach all those skills in our classes because we know how it goes. Oftentimes it's hard to fit everything in the technical class that we are already teaching, but there are opportunity.
Yeah, and to add to that, in my Sustainable Development Engineering group project, I require them to work with this collaborator of mine. So I've selected him, but he's not an engineer, he's not an academic. So I briefed him, but my students have to set up meetings with him. You know, he's got his own schedule and then work to implement it. So I'm, in essence, forcing them by telling them you need this to get points for your class to, you know, hold meetings and then be able to please this stakeholder of ours and then write up how the meetings went. And then I'll follow up with my collaborators to see how those meetings went. So in essence, forcing my students to have these interactions will be good preparation for their professional life. And then tying into the question there from James Mihalsic in the Q&A. When I was a graduate student at USF, Jim had the program where we had classes in anthropology, classes in public health, and then classes in sustainable development engineering. So like the other panelists have said, having the opportunity to take classes outside of engineering, interact with students outside of your own discipline. A lot of times students have best of intentions and they just need practice and exposure, and taking classes and having course projects are ways to get that practice and exposure.
So just to verbalize that question from the chat, is it best to implement these programs to develop a global mindset, to travel internationally at the undergraduate or the graduate level? And I think Annalisa already kind of mentioned, we can do this at the undergraduate level, even in the coursework or in course selection. So any additional thoughts?
Well, I love that question from Jim, and I think the answers that people are offering, have been very insightful. One of the things that I would encourage us to think about is what is it that our students are trying to get out of this experience, right? So in perhaps like in one scenario, it might be poverty tourism, and we might look at that and be like, okay, is that really what I'm going for? But you know what? There are still value in awareness raising in something that might even be mischaracterized as poverty tourism, but like so there is that side, right? Then there's the people who like, I want to go into this for a living. I think the nut that is hard to crack is to figure out where do you make your livelihood in this? Like some of us can do this in academia. Some folks might land at the Gates Foundation or something, or might land in a UN agency, or might have landed with what was once USAID, or right. So I think we haven't figured out how you get paid to do these good things. And part of my own research there has been on the fact that these activities are caring activities, and they suffer from something economically that's called the care penalty. It's the same reason that many women predominant professions, whether it's nursing or elementary education, tend to earn less for the exact same skill set. Environmental engineers tend to earn less for the same or even higher skill set. We tend to do something that's really good for others, and we don't do a very good job of internalizing, of pricing the value of the stuff we add. And so if we would do a better job, and I'll give you like an example, I've got friends that are like, they work with Coca-Cola to help get water in communities in sub-Saharan Africa. And I look at that and I think, the gestational diabetes that those little kids are going to have with all that sugar they're getting is going to make it so hard to have a vaginal delivery by a midwife out. Like, please don't go that direct. And I'm not putting down Coke. I'm just saying, like, that's the kind of like holistic stuff. Coke's going to figure out how to make money at it. We haven't figured out how do we like get in there and actually drive economic value. We can do the caring part. So I would say that that's kind of, in my mind, the nut to crack to answer this for why students would learn it. They got to figure out how they're actually going to make a livelihood at doing things that are good for everybody. Oh, there we go. That's a good one, Jim.
So the follow-up question that Jim put in the chat, does anyone collect assessment data on how these programs influence student learning and success? I think Annalisa mentioned a little bit of her student feedback, but I know my thought was also maybe a bit more of a compare and contrast, where Annalisa is taking her students to Europe that arguably have more stringent environmental goals than we have in the US and regulations, whereas Kevin is taking his students to Costa Rica, where they were seeing the other side, where there is less funding and less government restriction. And so there may be some less than ideal practices being employed. So if you have the option as a junior faculty between sort of Europe versus a South America, which could have more outcomes, more improvement in global mindset for students, and how could we even go about assessing that in the first place?
I could start. So we do have for our NSF IRES formal paid evaluator for our program. So it's not evaluating the students, it's evaluating the program. So the students take, different surveys beforehand and afterwards to see if they grew in their cultural awareness, if they feel more comfortable with their language, with talking with people in a different language, and so on. So it's been really informative and helpful for me to see some of the tools that the evaluator has used. And we have taken the feedback from the program evaluation from the first year and then try to address it and improve upon it in the second year. And we'll do the same thing before the third year. So having this evaluation of student learning and how well the program has been successful or not has allowed us to improve the program for future cohorts.
Yeah. In my case, we do formal evaluation of just of the program in general, what the experience for the students. But we have tried also to, with other colleagues that do other dialogue of civilization, really trying to learn how they go into before. So do a questionnaire before and when they come back, how they answer the same question to see if they're a little bit more aware based on their experience. And what we have tried to do, it's also try to follow up after a few years from graduation, if what is the career that they have chosen, and if that experience has somehow it's linked to that experience. So it's not really quantitative because at the we don't have 1,000 of students to test, but we have tried to do it. We actually were trying to get an NSF funding to do a little bit more comprehensive study on how to evaluate how this type of programs can change and form the students. We didn't get that funding, so that we couldn't do it formally, but we're still trying to do it informally and collect data on the student that participate in this program.
Those are awesome. Those are awesome answers. So what I would add on is that I would also ask us the assessment towards what, right? So again, this is the V shape, right? How do we point towards the common future? So, for example, in environmental engineering, we would basically say from the American Academy for Environmental Engineers and Scientists, which establishes what is the body of knowledge for environmental engineering. They would say, hey, here are these 18 things that a fully functional, highly competent across the whole spectrum environmental engineer would be capable of, which would include sustainability and some of these durable skills. But we might look to other programs. And so just to give some shout outs, right? So like, for example, there's the Engineering for One Planet framework, which is a partner for the American Society for Engineering Education's Environmental Engineering and Sustainability Division. So the EOP platform is there, which is a great one. But, Carl Linden and a whole suite of folks at the Mortensen Center, there is a whole humanitarian engineering body of knowledge document. There's the Peace Engineering framework that Joe Hughes and the Drexel folks have done. Bernard Amadei recently just came out with a Peace and Diplomacy Engineering book that you might want to look at. So there's a whole bunch of these different options out there. If you're looking, again, just to kind of name drop, from an ethics standpoint, one of the people that I tend to go to is I look at Angie Billfeld's work, because she's got fantastic examples of how to have instruments for measuring how the things you're doing impact. Now, I will just do a throw out. I actually do a very, very simple economics one. I actually do a total cost curve. And I get all of my students, I ask them a simple question. I ask them multiple times, and then I lead up to it. But I ask them, how much would you pay for a sunset? And I get at the beginning of the semester about a third of the students saying the sunset is priceless. And I get about a third of the students saying the sunset is free. And I get about a third giving me a dollar amount. And as I go through the semester, I explain to them that 2/3 of you are utterly wrong. It is neither priceless nor is it free. It's not priceless because of opportunity cost. I can't put everything into one sunset. And it's not free because of the tragedy of the commons concept, right? Like we're going to erode something. So what we have to do is figure out, how do we get into the technology and what does it cost? And the beauty of the total cost curve is it brings in the value of people along with the cost of technology. So the way I get around the whole you can't use DEI statements is I explain in environmental engineering, we've always designed for the susceptible population. So when you start to think about, like, you can immediately blow away this whole idea of everyone's the same. And you're like, no, a little baby, somebody with HIV, and an elderly person are not the same. And that's why we designed for them, as opposed to the average, more or less healthy middle-aged person, right? Susceptible population. So the beauty of a total cost curve and the way to track your students' mindset moving is if you can get them to start to debate that, like, intersection of the cost of what it's going to cost to people's health and their livelihood and their lives, and what it's going to cost for your technology across a gradient of something like, pollution or goodness or whatever it is you're looking at. I think you can move them towards, like, getting away from the politicized polls and then start actually grappling with good stuff in the middle. So that's the way I try to tackle that.
Pivoting this into student outcomes and sort of the economics when they all get careers, hopefully, after they graduate, how would you recommend that a student market themselves as having the skills of this global mindset? We can't put skill in global mindset on our resumes in the same way that we might say competent at Microsoft Excel or can use MATLAB. How do you recommend students to demonstrate to future employers that this is a skill set they have or that they are actively working to acquire? Or maybe even, do we have the tools as environmental engineers to do that and value that yet?
I would venture how I do it, and maybe let my colleagues think of their answers. So I do it through insurance. I do it through actuarial science, right? So if we look at climate change and we look at how do we understand the pricing of climate change, the field of attribution science, right? In other words, how bad is that storm? How bad is that wildfire? How bad is that event? with and without a climate that has been impacted through the release of greenhouse gases, right? This is being held up in court pretty well. It's a way to be able to price that which was previously unpriceable or could not be. So it internalizes to a full life cycle items that we historically were not able to price or count. And so I tend to turn towards my students and say, let's understand attribution science, let's understand actuarial science, let's understand life cycle assessment, not about paper or plastic bag, which is an interesting question to ask, but actually more in full cost accounting of what you're doing. And I know it might seem like a gross point to say, well, so Dan, you're going to like put values on like people's homes and lives. Well, my friends, we already do it. That's how insurance works. So I'm not being any more crass than the insurance industry is. But once you start having your students understand that how they design stuff in Florida and how the storm surge from a hurricane is going to decimate infrastructure and how you're no longer going to be able to get affordable flood or hurricane insurance because of pricing, or you're not going to be able to get the second home in the mountains of Colorado or overlooking Los Angeles. Now suddenly people are like, wait, there's actually money in this. And so I find actually the insurance markets are a place where I encourage my students, where I teach them the skills that I think they're going to be able to list on their resume to price the value of the knowledge they bring.
Yeah, and to add to that too, I feel like a lot of the things that employers want, they want a student who can solve complex challenges, work with people different than them, work in new environments. These are all skills that they can develop that would be considered like having a global mindset, to have people who have different values than them. Like these are all skills, so they can describe it in their cover letters. And when you're often in a job interview and people ask you, like, give an example of, how you solved a problem in a complex situation, or you had a disagreement with someone from a different mindset. I feel like students who have had these, global mindset experiences have very real, very clear answers that they can give that are persuasive to their employers.
Yeah. And to add to that, to practical, like on your resume, if you do an experience that has the component, you should definitely put it there, emphasize it. And even if it's not going abroad or a study abroad experience, it's even a project within a classroom. Like if you can put a little bit on the detail or in your resume and put that information there, that is, it could be something that an employer might be looking, and at least you put it there. That means that you have had that experience. It doesn't have to be a 1 year the Peace Corps to have that. It could be also as simple as a project where you thought about this problem from somebody else's perspective.
All right, so one final question then. For our junior faculty and future faculty that are on the call, you've given many different examples of trips and in-class assignments, working with the gardeners on campus, making little fire stoves. Where would you recommend for a junior faculty that does want to just create a classroom assignment or a project in a single class? Where should they start?
There are a lot of resources, I would say, even published work on how to implement global mindset in the classroom. So I would say do the little research on a lot of people. We are not alone, right? A lot of people have done a great job, a great work before us. So I would start doing the research. How can I do that? How other professor have done that? Participate this type of webinar to get additional idea, and talk with colleagues and see how they do it in their classroom. I think there is a lot of information out there. We don't have to reinvent the wheel. I mean, we should be more creative and use AI, for example. I love your idea how to simply implement AI to get that experience in thinking about sustainability and sustainable development goal. I think there are a lot. It's a lot out there. So starting that, I think it's the first step.
And I'll add, like, if there's anything that was appealing from us, feel free to reach out to any of the panelists here. The one activity that I really love that's really easy to implement is the community mapping exercise. And I have students like draw the campus and label places that aren't sustainable. And that's a clear student-directed exercise to see like where are there issues on campus, and those could be things that you could eventually address through a campus project. But just having students do something interactive, working together, thinking about their own context, I think that's a pretty easy way to start.
Now, I'm going to give the old stodgy, lots of gray hair, lot and the beard, not much hair on the top. I love those answers, right? The other thing I would say is I would add to it is find your allies in your program and talk with them. So, for example, it can be really exciting to set in your own office and be able to work on your own stuff and suddenly like go down a pigeonhole that the people who are going to be evaluating you say, no, that's not the right thing to do. So I am not suggesting that that for kind of people on their career that they don't do what they're passionate about. I'm saying one of the important questions about getting a job is what kinds of things can you do as your passion projects and how will you be judged for those as a faculty member? And if you're getting really clear signals like, we're not going to count that, that doesn't matter, then proceed at your own risk. I'm not saying don't do it. I'm saying proceed at your own risk and realize that passion projects should be driven by your passion. So find your way to be passionate about it. But make sure that you've got some buy-in by the folks around you who are going to be vouching for the work you're doing. There's loads of us out there that will give you help and give you resources. I mean, obviously the three on here, but plenty of others, but make sure that you've got your advocates and your champions there at your institution that are helping you navigate how to do that. Because there are some, particularly outside of our disciplines, that might not understand this very well yet and might wonder like what it is you're doing. So you want somebody to be able to help translate that for you.
All very good points. Thank you to our panelists. As has been true through all the Q&A, our emails are all up on the screen if you wanted to take a picture or copy anything down in order to contact any of us about the course material that was discussed or any of the perspectives that were offered to continue those conversations. Now, just a couple of closing announcements, giving some more shout outs, if you will, to some of our partner organizations as well. So AEESP Education Committee is going to have our next webinar focusing on the Scholarship of Teaching and Learning, or SOTL, in mid-November. As was mentioned, ASEE, the American Society of Engineering Education, there we go. So those of us that are more on the teaching focus side of the house often find that the Environmental Engineering and Sustainability Division is a good place to share ideas and publish. As was mentioned, you can find papers in those online repositories with ASEE if you're looking for inspiration about different assignments or activities that you may do in your classes. And then finally, a special shout out to AAEES. So many A's, so many E's, so many S's in our society names. They are getting ready to celebrate their 70th year, and a special shout out for some of their upcoming webinars. In just about a week, they'll have a webinar focusing on leadership development, essential skills for effective leaders. And then if you're still a bit more on the technical research side of the house, they'll have a presentation from flood zone to future-proof, California's first MBR and IBR mainline facility. That'll be happening at the end of October. So as a group, we hope to see you at one of our many future webinars at any of these societies where you're sure to find a very good and supportive faculty community in order to advance your career. Thank you very much for joining us today. Bye-bye.